of the water industry. I'm Jack Audie, EIS's Director of Sales and your host for this webinar. This webinar is being recorded and will be made to all registrants. So first, here's the agenda for today. We're going to start off with a quick introduction. We're then going to do a poll to get some ideas of some questions of what people are using. Describe who is EIS. We'll then talk about the digital evolution of the water industry, followed up by a demo, next steps, and questions. So before we get started, here's some Zoom basics. If you want to ask a question, there's a Q&A document, a dialogue right on the Zoom bar. You click there, and we will either address them during the presentation or at the end. At the end of the webinar, you will be presented with a survey. Please answer the survey. We would appreciate it, and that'll help us gauge the usefulness of this webinar and its overall effectiveness. So, first I'd like to do is introduce today's speaker. Kevin, can you introduce yourself, please?
Absolutely. Thanks, Jack. Thanks for everybody for joining today. My name is Kevin White. Been with EIS for about the last 4 years. Done stints in multiple industries at different roles. Started my real operations a few years back in the Navy as a nuclear engineer on a submarine. From all these, I gathered a lot of commonalities. I guess you'd call me a generalist. And I'm hoping that today I can kind of show you how those opportunities of focusing on operators can help with our digitization efforts in our plants. So looking forward to it. Thanks, Jack. Jack, you're muted.
We just launched a poll. Please, if you get an opportunity, please take the poll, and I'll share the results.
Jack, will you probably move on from the poll?
I think you're right. Let's do this. I'm going to share the results now. So the question is not only a couple of people answered, but we're using the following process historians. Some people are using something else. Some people are unsure. Who are the main consumers of these data? Operators, supervisors, and managers, pretty much across the board here. And the main uses of this data is everybody uses them for dashboarding, also for a post-mortem review, as well as real-time decision-making by the operators. All right, thank you very much. So what I want to do now is discuss a little bit about and introduce enhanced information solutions. We were founded 29 years ago in Stillwater, Minnesota. We do MES consulting services and implementation services, PI services, SEEP, OT cybersecurity. We have three main products that we have, and you're going to see them today. E-data sheet for manually entering data into your Pi system. Ops tracker, which is an electronic logbook with real-time connectivity and workflow, as well as Pi Event Frame Manager allows you to create and edit Pi event frames. We also do a great deal of OT cybersecurity, and like I said, we've been around for quite a while. Our locations are our brick and mortar offices, headquarters is in Minnesota. We have offices all throughout the globe, actually. With the actual brick and mortar offices are in Minnesota, Toronto, Canada, San Juan, Puerto Rico, Dublin, Ireland, Mannheim, Germany, Pune, India, and Istanbul, Turkey. So the Pi services that we offer here is we are an AWWA endorsed partner, as well as an OSI Soft Premier partner. We do Pi AF development. We have a great deal of operational experience, so that's something that is required when you're deploying asset framework, template designs, asset-based analytics. We do a lot of process book to Pi Vision migration. Since OSI has stopped the use of process book, there's a lot of them in the field. We specialize in the process book to Pi Vision migration and leveraging the features of Pi Vision, as well as machine learning, Pi integrator, and cybersecurity for OT assets. All right. With that said, Kevin, can you please take it from here?
Thanks, Jack. So what I'd really like to talk about is a solution-based approach. And what I want to kind of take you through is how I came to what you'll see in the demo. I'm coming from a military background, so I really got to see both in the military and in our manufacturing plants and operations that our true value add is at the operator. So when I went to ACE 23 to talk about the demo that you'll see here in a second, I realized that the top concerns at ACE 23 really aligned with that. And the first of that is that institutional knowledge transfer. We're seeing it in every industry, but we're also heavily seeing it in our utilities. I've heard the term silver tsunami, right? Those operators who have been there in the trenches all these years, who have this institutional knowledge, are having a hard time passing it down, large part because there's a huge gap and the new people coming in may not have the same background traditionally that we've had coming through this. So it really becomes difficult as these people leave our workforce. Who's filling in that knowledge gap? The next thing is, we all know this in any industry, in any job right now, we've got to empower our workforce or else they're not going to stay. And if we're trying to build this knowledge transfer and empower these workers, how do we make sure that all that information that was gathered over years of really hard operational learnings to be transferred to the new operator so they don't get discouraged and walk away? And then lastly, this aging infrastructure, which every single utility is dealing with right now. And there's maintenance programs in place, there's capital expenditures in place, but how do we have the operators help make the life of the plant go longer? How do we use that data on the floor to better operate our equipment? And so hopefully you see that I'm looking for problems to solve, not a tool to just slap at. Okay, next slide. So here's a graph, again, not mathematical by any stretch of the imagination, but it really shows how we approached an output we wanted. I'm an engineer at mine, so I see inputs and outputs, and how do we get what we need out of the system? Well, with our people, we really relied in the past on that operational experience, right? Those who had known, seen, and done, who had hit roadblocks before and figured out how to get around them. They had a little bit of digital tools, but some had none. And those who had it, it was an accessory more than something they really needed, right? Maybe a recommendation. Okay, the next one. So we know, first of all, that operational experience going down, right? We've seen that in our plants, and we're not going to get it back anytime soon until we start building it back. And that's a longer term project. However, we know that if we leave the same number of digital tools on top of that drop in operational experience, you lead to a large gap. And that gap is when errors occur. That gap is when people get hurt. That gap is when an operator spends their entire shift trying to figure out what the person before them did and why, right? It's that lack of visibility and knowledge where you could trust the person before you to do it exactly the same way you had done it because you had been trained in that way. When we have that drop in operational experience and that lack of transfer, it's going to leave this huge gap. So let's talk about the future. First of all, operational experience, like I said, until we build it back up, we have only got to assume that our lowest common denominator is going to get a bit lower, right? The people who are coming into these fields are comfortable, however, with digital tools. So we can maybe increase that a bit and say, hey, we can now combine these two in an interface where that new operator, because they're comfortable with digital technology, can maybe gain some of that operational experience, but not through running through that roadblock, but being told, hey, there's a roadblock there. Here's how you get around it. Okay, next slide. So this is the old traditional way where things flowed up. An operator's picking data up from the floor, and then everybody else gets to profit off of it, right? One of the good things I saw in that poll is data is being used at all layers. The really interesting part is that same data point is then massaged based on context for each of the managers. Next. So as that data is collected, it flows up the hill, up to the supervisor, up to the manager, who are taking in other contextual points, specs, quality trends, cost of maintenance, outdoor weather, looking at all these different things and saying, okay, with this data and with this context, I can gather this information. Then usually what happens is through there, it gets driven back to the floor. Here's what you need next. Here's what you need to do, right? What you need to do, next check, is through procedures or training or, don't you remember, or we put a little placard up, you should, look at it every single time, or here's your, here's a flow chart. Each of those things are hoping to take that data that they're collecting and drive it into actions. Problem is, and you can see this, is that operator doesn't always have control of that, right? It really takes that feed up the loop to come back down. That's not going to make people feel good, right? If all they are is a data recorder at the front line that aren't being kind of involved in this information, that's unfortunate, right? Especially if we're trying to empower people. So what we can do now digitally is we can get that group knowledge that allows that information gathering and that synthesis and that flavor to that data. Instead of saying, oh, you've got to be here for 40 years to understand that, we can say, hey, let me explain this to you and put it in a digital format that allows you to take advantage of my knowledge for you right now. Next slide. So this is kind of how we see that loop, right? And that loop means everybody's looking at the same data, the source of truth, right? And in our case, we're going to talk about a historian, Pi, which is going to gather that, an asset framework, which is going to pull in other databases, and that will be our source of truth. And we're all going to operate from there. And we're going to build metrics from there. And we're going to show screens from there. We're going to run procedures from there. We're going to enter data into there. And that will be the way that with a single point of truth, we're able to see all of that information, not just the data points. Because what asset framework allows us to do is contextualize that data so it turns into information. So now your frontline operator, instead of having to pass that up the chain, has that institutional knowledge instantaneously. And not only that, now as they start learning more, they're going to be even more empowered to think more and to question more. And their time won't be spent taking and doing, right? It'll be synthesizing, analyzing, and looking for improvements. So as the supervisor is watching that same data, but on a higher scale with different metrics, they can now make changes to the system in real time. We're going to talk about the tools that we use to do that. But before we talk about the actual tools, next slide, I want to talk about good tools. So as an engineer across multiple fields, there are many a project that some operator will complain Kevin White pushed on us. And I've learned a lot from those failures, because those are always failures. If that's ever the way it's interpreted by a frontline operator, you have lost the ball game. It could be the best thing ever. So really, I had to distill back to what makes a tool good. And the first thing is it can't just do one thing, right? We got too much stuff to do. Any tool we have has got to hit multiple use cases. Second thing is it's got to be easy to use. I'm not a computer programmer. I'm not a computer guy, but the tools I picked were because they were easy to use. There was a whole lot of videos on how to do stuff that are pretty easy to follow. And then for some of the new tools, they are drag and drop. So I don't have to worry about programming and what the connections are. Once it's set up, I can have use cases that continue to drive forward. And that's the last part, is the in-house ownership. The tools I'm going to show you today, they are meant to be handed off to you so that you can continue to build with them. You won't need EIS sitting over your shoulder saying, hey, I want to do a new procedure. Go, okay, well, that's going to be this many hours that we'll have to build it. The idea is at the end of this, right, you've got the subscription pricing on the softwares, but you own it. Your supervisors own it, right? And you'll see in here that we can actually get to real-time corrective actions. We'll talk about that a little bit more as well. Next slide. So the tools that we're going to be introducing today, again, I saw nobody said they had Pi. If you think of similar, the terms are historian, right? So anything that's pulling those points, right? And they can be from different sources, and it historizes them, which means it records it with a timestamp, and you can do some cool stuff as far as analysis on those points. So with the Pi core suite, you get all of this. You get the historian, you get the asset framework. And what that really does is it allows you to build the data in a way that then you can contextualize it. And then Pi Vision can show information instead of just raw data, right? We've got HMIs that are showing raw data, but that's a single point in time. And even if they have a graph, maybe they don't have context with them. Then we're using another tool called Ops Tracker. That's EIS's offering. There's 2 modules in there. And again, I am an operations person, so I'm looking for an easy tool, dummy proof. These are jokingly called so easy a Kevin can use them. The first is eData Sheet, which is anywhere you've got a log set, you can actually go and take that away and enter this, and it'll write directly into Pi. Why do you want to write it into Pi? Because if not, it's sitting somewhere else and you're not utilizing that data and all the things that your asset framework for contextualization can provide. The second one's called eForms. Now, if you think of eForms as a decision tree, if I move down a path, I look at 2 things. If one, go left. If not, go right. Now you're on a new branch, following that branch. So these decision trees, if you really look at it, that's how our procedures are written. Do this step, sample, see where you are expected. Now do these follow-on items. Here's the part about it though. That process, if done the same way every single time, yields awesome results. You can easily guess how many times it happens in the plant the same exact way. So that standardization is really what eForms brings to operations. Okay, next slide. So I'm going to walk you through some current operations right now of where we're at a water plant and we've got this manual log entry, and then we're going to have a paper operating procedure. I'll kind of walk you through it here in the next slide. So starting with this nice yellow piece of paper, we have an operator who goes out to the floor, scoops up a little bit on their treatment basin, takes it back to their wet lab and does all their manual analysis, right? And this could be shiftly, it could be after an ad, it could be whatever your periodicity is. So now from here, if you can click Jack, I fill the numbers in. I write them down on a piece of paper. So you're like, well, why did I write it down on this little piece of paper? Wouldn't it be better on a big log set? And they go, aha, I got even smarter. I'm going to put all these together, next Jack, in an Access database. So I'm going to have them write it on a piece of paper, then go over to the control room and put it into this Access database. Some plants don't have that portion and just keep it on the piece of paper, and that's your log review to look through. Other plants put it into a electronic format. This is an Access database. Other will put it in Excel, mainly because then they can take it from that database and massage it with other variables to turn it into information, trending, tracking, things of that nature. The other thing, and we'll talk a little bit about this, is a lot of these plants also have to do some type of regulatory reporting, which aggregates these values and other values in the plant on a daily, weekly, monthly basis. So all this on paper or in separate systems means when you have to report that out, you got to go to each of those silos where that data is, aggregate, massage, and then put into a final form. Having done that, I know it's a pain, right? And it takes us a ton of time that we could be using on actual operations that we're using to pull all this data together. Okay, next slide. So the other thing with this that I don't see is, are these numbers good or bad? Right? Is 26 a good number for calcium? If I'm a new operator, I go, oh man, what did I get trained on this? Or maybe the supervisor wants you to do certain things at certain times. How would you know? So we'll give our new operator a hint here and say, oh yeah, by the way, here's 2 sheets that you can use for flow charts to tell you if you have to do something or not. Okay, so let's start with the pH at the top, right? And hopefully they start at pH at the top, because if not, they could not even follow this flow correctly. So next Jack. So there's our pH. So we read our 2 rules. Don't worry if you can't read them. It's meant to be small like that. So it says, okay, so my pH is in these 2 bands. I don't have to do anything. So next thing I go down to is total hardness. And total hardness now says, ooh, I'm in a high out of spec. I have an action point. Now, whether that's an out of spec per regulatory, whether that's a plant condition, all those things are unknown at this point, right? Is there a multiple level? Is there a high and a high? None of that is shown visually right here. So it's very hard for an operator to know if they should do something or not. So we'll go, okay, so I'm above 96. Okay, so now I'll look at my calcium because that's the next thing I need to look at. And I see I'm in that middle bucket. Okay, next data point I have to get is the upflow meter. Okay, wait a minute. That's not on my form anywhere. You're right, because it's actually on a PLC SCADA screen sitting next to you in the control room. Next screen. So what you can see is you're now mixing manual data with live data in the system and having a human be the one who puts these pieces of the puzzle together. What I'm going to show you is, what if we put all these pieces together digitally and then let the operator get the answer from it instead of having to be the synthesis. Next slide. So now after all this, it tells you, one more, go do that lane in the middle. Now, how often do you think that happens, right? How often? I will tell you, when I found these originally, they were coffee stained and stuffed behind something. So if you don't have this happening every single time, triggering in the same exact way, you have a system that's not in control and the actions are not standard, which means you can't get to a control, right? Okay, next slide, Jack. So now Jack's going to give me control here, which is always scary, and I'm going to walk you through the actual demo. Before we get going, are there any questions about what you've seen or any of the systems being used? Jack, if you could check out for that to make sure anybody's got a question, we get it answered. Awesome. Can everybody see my screen? Jack, you good to go? I think you're muted, Jack.
Sorry, there are no questions. And yes, I can see your screen.
Okay, cool. Thanks, sir. So let's look at what we've got here. This is PyVision. For those of you who aren't familiar with it, this is the visualization of what's built together in Asset Framework. And I'll show you that here in a second. So you see, you can actually combine different things. You can have real-time pH probe, right, which is sampling the water. You can have manual data entry, and we'll show you how that happens in a second. But then you can also do some other higher level things. You can do aggregates, right? So you can do the calculation behind the scene. Instead of saying, yes, we're pumping 484 pounds per hour right now, and the person goes, is that good or bad? Really what they care about is, what is that aggregate to this point and what's the average? So you can show these graphs, which are higher level analysis of the basic level data. But if there's something that you need as a base level data because it shows you plant response, say like level, now you can put that in here. So from this screen, this is all PyVision. This shows you what's on the backside built in PyAsset Framework. So we'll go through our operator example and you get to see each of these. So I'm going to go to, this is Ops Tracker. And I'm going to sign in as a water operator because I've got to go around and I've got to do my logs, right? And I've got to go take that sample. So I go to eDataSheet, and I'm going to take my clarifier East sample. And I'm going to use the same exact numbers that I did when I sampled on that page. So we're using the same exact scenario. So let's see, calcium was 26, 67, 10.89, 98. You know what? I'm going to do something fun here. 0. Now you'll see that I got a red block here. The nice part about eDataSheet is you can build these boundary conditions. Now these boundary conditions can either be a specification, right, where you have an in spec and an out of spec and you want to call it out as such. You may have an expected range. So I know a lot of the times we're entering data in, we spend a lot of time scrubbing out fat fingered data. So instead of it being 80 to 100 and you type in 1,000, you go, it should not be at 1,000. You want to check that again, would turn it red to visualize that for the operator. So you can choose what those boundary conditions are when you set up the form. Extremely easy for the configuration. The other thing you can do is this nice little toggle switch, no programming. Like I said, I'm not a computer guy and I can make these quickly, is it allows you to choose what happens if you put a number in that's red. One option is it says, okay, it's red, saving to Pi. Another says, okay, it's red, but I won't save it until you add a comment. Now you notice I can add comments on anything. So let's do a right click, add comment. Probe looked dirty because it was inspect, but I really know that, yeah, it's going to look like it's maybe going to skew my next sample. So I want to check that out. So I can save that. Or the third option on red is I don't accept red, right? So when you're done putting in the numbers you want to put in, hit save, and you'll see it'll save successfully. So what it actually did, and this is the Pi asset framework we've been discussing, is it wrote those numbers. There's our 0, there's our 10, 8, 9, 98. It wrote it all to our Pi asset framework. So the reason you want it in this asset framework is so you can do things like set a high and a low. So you can combine SCADA points with manual data points. So you can do operational metrics that are doing a summation and a totalizer for these SCADA points combined with this. The last thing you can do here is you can do an analysis of the system. So you can check each of these and build it into what action is actually required. And this is actually built really simple because it says, if this, then this, and here's the actions to take. So there's the 20 actions that were actually shown on that sheet on that previous example, all mapped out, right? Because we know those conditions. We've just put them all together digitally. So instead of having the operator go gather it, figure out where they go down the path, we're going to give them that answer. We're going to say, hey, here's your plant conditions that you just entered. Right away, here's your corrective action. And all we do is we map it out to a Pi point. And the reason is, you'll see in a second, is because we can use that Pi point to do a lot of fun stuff. The first thing we're going to do before we go out there is another functionality that eData Sheet has. Because it's connected to your Pi system, you'll notice there's pH Probe, which is a live PLC SCADA system coming out from the system somewhere. But maybe we want to use that because we check it against our pH sample for some comparison. So we want to show it here. So if I hit refresh, and it's not going to do it now. It's not doing it now. It will pull through this number through RDBMS, which is what Pi uses, and it will pull a tag through. I think I may have waited too long between entering it and refreshing. So let's go back to our screen here, and you'll notice something hugely different from when we first showed it. Hopefully, it's this big orange button that says East Actions. So the great part about that manual data entry is you no longer have the silo. The great part about asset framework and visualization through Pi Vision is we can say, hey, based on the data you just inputted, you are in a condition that requires actions. Do something. That's where like 95% of our tools end. Because the next part is, okay, go follow this procedure. Oh, go do this. What we're trying to do is we're trying to take that out of here. You'll notice that the only thing we ever put up here is if you require an action, should be, okay, what action do you want me to take? And that's where eForms comes in. So eForms allows you to say, hey, here are those conditions. You need to take an action. Here's what you need to do. It will walk you into the procedure. Now, again, this may not solve every single problem. This is an 80-20. But if you can get 80-20 on your initial kickoffs that at least move you down the road to a correct answer, you're already doing a heck of a lot better than people who, first of all, don't know they should be taking an action, right? Or even worse, take actions when they shouldn't be because they feel like, yeah, now is when we should take an action. So you'll notice the first two steps, and I'll show you behind the scenes here. The first two steps are actually doing a call to Pi through a REST client to look for that number. So it says, hey, that number that was calculated in Pi Asset Framework based on the data that we could digitally look at, here we go. It's response 14 from that if-then statement I showed you. Now look at this. This is every single corrective action you could take, all right? There you notice is a cut and paste from what you looked at. I didn't go rewrite anything. I literally did the snip button and cut and paste. So what I did was on building this form said, hey, this is corrective action 1, 2, 3, etc. So if this number that I pull up here from my analysis in Pi Asset Framework equals 1, show me this one. 2, show me this one. And so now you can see with that 14, the only one that will be shown is the correct answer. So instead of asking our operator to figure it out, We're going to let them do this. Now, the other nice part about it is when I'm completed, I can save it, which means now that operator has completed this. So realistically, if they're only clicking this when they complete the increasing lime operation, now you can say, hey, we did the standard procedure. Did it work? So again, it says to rerun the analysis in 30 minutes. So I'll close this out. I'll go back and pretend we're future in the 30 minutes. I'm going to save that. Again, you'll look for the gray to say it's saved. And there we go with the timing. So now you can see that's what that pH probe is actually reading on the screen right now. And you'll also see that button disappears. Why? There are no more actions for the operator to do. They have followed through with the procedure. They've resampled. They've brought it back into spec. Now, another scenario may be they sample and they're in a whole nother branch of this thing because the complexity of water chemistry that you guys know about, right? So that's got to be something that's in here. It's not, we just did the action, it's good. It's, we checked, here's the new conditions, here are the next steps to take. So that's eForms and eDataSheet. One last thing I want to show you as far as the reporting is with something that's native to Pi, because of the way things are writing in SQL can be pulled out of and searched. So if I click on this button, it can take me to SQL Server Reporting Services. Again, I set up this link. And what I'm going to do is I'm going to pull a report that it will automatically generate for me based on values that are saved within my historian. So if you've got a monthly report, weekly report, things of that nature, it can automatically generate it for you. Again, you can format it so it looks whatever it wants to look like at the top. This is a kind of a play on the MDH report for chlorination here in Minnesota. And then you can see that it goes back and it finds these values for you. All you have to do is set up these calculations running on a daily basis, and it will always give it to you this way. So pumpage shows you can do a beginning of the day, end of the day delta. That's what this column is. Gallon added per day is actually a calculation of a flow rate times the time it was running. So if it shuts off, we're not counting that flow rate, and you can do really precise calculations there. And on this one, the daily average chlorine is actually from what you've now entered in your sampling sheet into Pi, where before that was sitting on a whole bunch of log sheets you had to pull together, right? So you can imagine pulling all this different data together. Once you bring in that single layer of truth, now you can start reporting on it. You can start having better metrics on it. And now you can look apples to apples and oranges to oranges, right? So that is what I have for the demo. So I'm going to turn it back over to Jack Oddie.
Okay. So we do have a question here. Let me do this. Share. You have to make me the host there, Kevin.
Yep, sorry about that, Jack. No.
Okay. So there was a couple of questions here. One of which was everything we talked about here was Pi-centric. What happens if the database is, what happens if it's not Pi? What if we want to do manual data entry and still have a workflow and do this, and we have just like a SQL backend?
And that's a common question, Jack, because people see these tools and think, oh, I need all these to get all these benefits. The nice part about this is we've really broken this up in a modular way that you can take advantage of each of these tools individually. And then when you add them together, it doesn't just, it's not a straight line improvement. It's an exponential amplification. So the backside of Ops Tracker is SQL. So anything that you can do visualizations through Power BI, connected databases that way, can all be done with data recorded in eDataSheet, which again writes to a SQL table, and your eForms, which writes to a SQL table. So you can do metrics such as workflows per day, or how many steps completed through a workflow are we for this workflow. All that kind of metadata is sitting backside on Ops Tracker. Now, the nice part about it is this can live in its own independent world with SQL, but if you also want to integrate those opportunities with the system that's got all your, usually your PLC data. That can be anything that has the ability for an API. So in our case, we use Pi, right? But anything that you can pull data from a PLC middle system, right? And there are multitudes of them. Then you can pull those data points into the SQL table and reference them, right? It's a little more difficult. It's got this tool set has a lot of native functionality with the Pi system, and Pi's done a really good job of breaking them down from being we can't afford Pi to a subscription base. So actually all three of these, if you did them together, would be roughly $24K per year for 5 years for just the licensing fee for software. And then I think if you did all three as far as an install, it's right about 70K. But after that, you run with it. You are trained to do your use cases and such. So to your point about systems connecting into this, this is built with this tool set. However, all tools are really interchangeable.
Yeah, let me just add to that. So if you look at eDataSheet, and what I do have is let me pull this up here. I'm going to share this. So Kevin, can you see my functional architecture?
Yep.
Yeah, so what happens is we have this ops tracker server for eDataSheet and eDataSheet and ops tracker. And we have, like Kevin was saying, we have the SQL Server backend, and we have a web client. So right now, one output, we have everything stored back here in SQL, but one of the output destinations, the most primary output destination is Pi. There's no reason why this couldn't be Factory Talk Historian, IP21, or something else. Right now, this is the one that, but this in the blue is all the same. And what we do is we can determine whether that output goes to a Pi or some other database, or just maintains in SQL altogether. Okay, let's see, any other questions? Oh yeah, here's one other question, Kevin. What about does this have to be done all at once, or could this be done gradually over time?
No. We've broken it down so that we do a front-end engineering design, and then it can be piecemeal, right? Because the thing about it is you don't want to install, I never want to come away from saying all you have to do is put this tool in place. The way that this tool gets accepted is because you have a pain point and you address it with a tool. So each of these tools have different parts to play. So based on what your highest level priority is what I would recommend first to go after. So if you've got a bunch of paper logs that you don't get to see digitally, I'd say, well, okay, well, use eDataSheet first, right? Get you to a digital set point. If you've got a ton of procedures that you need to make standard and you want to go paper to glass for those, I'd say go eForms, right? If you just need that visualization tool right now to get the first step in the door to use all that data and contextualize behind the scenes so you can visualize it as information, Pi works for that. Like I said, when you add those on, you don't just get a bump though. You start, when you bring on eDataSheet with Pi, you now break down all barriers to your equipment and then your ability for a human to enter data into that system. So if you don't have a meter on a pump and you don't want to afford to pay for it, but you really want that meter information because you want to track and trend it in real time, that person could go enter that information, and now you have that data point in as real time as that person records it. You want them standing there every 5 minutes doing it? Wouldn't recommend it, but you can use that. So eDataSheets removes those silos. Lab data is another big one. Also, if you're using Pi, you can connect live to other SQL databases. So your CMMS, your LIMS system, maybe a forecast weather from the internet. All that can be done with Pi and eDataSheet. Once you get to that again, though, you're at the point of, okay, so something's wrong. What do I do about it? And that's really where eForms takes over. And I've yet to find anything that is able to do it as easily and as quickly as eForms. So again, really how you approach it can be broken in, or it can be all in one shot.
Okay, here's another question. Thank you very much. Here's another question. Are the operator actions logged? Is there an audit trail?
Yeah, so this tool was built for, that's a good question. This built was tool for life sciences. So it's at the point where anytime something is saved, you have a timestamp, what operation occurred, how it was recorded, and at any point you can pull up an audit sheet that shows that. I've yet to find in the water industry for that to be hugely helpful, but it does allow you then to kind of prove that steps were taken, right? The idea being, hey, operator, I need you to go through these steps. You only know if they went and did it based on whether you see a system response. But if you don't see a system response, maybe they did it and you didn't have a system response. So they can give you that trigger. As far as auditing, the only other part with that potentially that it could be helpful for is for some regulatory reporting. If you have to have an audit of all sampling done, or if you have to have, hey, if this went out of spec, I took these corrective actions, and you have to be able to show that as a corrective action proof. But yeah, there's a lot that this tool can do that isn't even applicable, I think, for a majority of our actions, because really we're at the, for water industry, and there's, again, people and places in different ends of the kind of the digital maturity, but I would say a majority of municipalities are looking to start walking before they are running. And really, if any of those paths you take for problem sets will bring you light years ahead of where you are now, but it's got to be based on what an operator needs for tools.
Okay, great, thank you. Well, that's it for the questions. I think what we want to do is then, next steps would be well, first of all, we want to thank you all for attending the webinar. And there will be a survey at the end. And if we want to go to the next step, just reach out to Kevin or myself, and we can have a discussion, simple discussion, see what the next steps are. We start off with a front-end engineering design, just a discussion of your issues. And we'd be happy to do this and do a one-on-one and see where we go from there. But again, this concludes the webinar. The webinar has been recorded, and the recording will be emailed to everyone who has registered. So please take the survey at the end, and thank you. Have a nice day.